normal flu, if I get that, I'm going to infect on average about 1.3, 1.4 people, okay, if there was such a division.
Yeah.
And if those 1.3, 1.4 people gave it to the next lot, that's the second time it gets passed on. By the time that's happened 10 times, I've been responsible for about 14 cases of flu. This coronavirus is very, very infectious, so every person passes it to 3. Now that doesn't sound like much of a difference, but if each of those 3 passes it to 3, and that happens at 10 layers, I have been responsible for infecting 59,000 people.
What's up, Instagram? So today I wanted to use the clip that you saw right before this as a way to explain the multiplier effect. And so I wanted to create that analogy of the infection rate and kind of how that is similar to how the multiplier effect works. And I'm sorry if it's a little unsavory, but honestly, it's a really good example and it's a great way to see it in real time and kind of have almost a visual understanding of how the money circulates through the economy. So before I get into the mathematics of the multiplier effect, let's just break down what the multiplier effect is. And if you wanted to, you could make the analogy that the multiplier effect is similar to the infection rate itself. Okay, so how fast the infection rate is, or how fast rather an infection moves from person to person, is kind of like how the multiplier effect works. And the way we come up with the multiplier itself will be explained in just a little bit, but that infection rate almost is similar to the multiplier effect. And so the determining of how fast that infection rate will be is also kind of like determining the multiplier itself. And so in the case of the flu, right, it affects 1 to 1.4 persons, whereas the coronavirus, it affects 3 to 3.3 people. And so slight PSA of like, please stay home because that's why it infects people so quickly. But anyway, so obviously you can see that in the flu, if you were to look at the multiplier effect, it's not as big. The ripple effect of one person being infected and that one person's infection rippling through the society is significantly less than the coronavirus is. And so you can kind of think of the multiplier as what is the ripple effect of $1 being injected into the economy. And this is important because money has a ripple effect, all right? So if you wanted to put it in simplistic terms, before I kind of explain how it works in the government, okay? If we look on a simplistic terms, say I find $100 on the ground. What a day that would be. But say I find $100 on the ground, all right? I decide to spend $75 of that 100 and save $25 of that 100, okay? And the reason I'm differentiating between consumption and savings is important because that is one of the assumptions of the model that I'll be discussing in like a second. So of that $75 that I decide to spend, or the $75 of that 100, I decide to spend, I go to Marshall's and I spend that $75 at Marshall's. Now, that $75 will go somewhere. It might go to someone's wages. It might go to overhead. It might go somewhere. But no matter what, it's going somewhere. So let's say for simplicity's sake, the $75 becomes the woman who checks me out of the store, and say her name's Jane Doe. So Jane Doe now has $75 in her pocket. So that's how it comes to her through wages, okay? Well, let's say of that $75 that Jane earns, Jane decides to spend $60 at Target. Betrayal. But anyway, she decides to spend $60 at Target and save $15 of that $75, okay? Now, while she was checking out at Target, this cute cashier named John Doe decides to ask her on a date, okay? And not because he ends up pocketing her, her $60 through wages, but because he thinks Jane is real cute, okay? So John now has $60 in his pocket, again, through wages, similar of how Jane earned her $75. All right, and so then John and Jane go out on their date, and John decides to spend $30 on the date, and then he saves the $30 of the $60 that he earned in wages. Money can't buy love. Y'all, why am I writing a fantasy right now? I think this quarantine's getting to me a little. Anyway, so And then say of that $30 that John spends on the date, the waiter takes home that $30 and the waiter spends all $30. Okay. So in the coronavirus video, he talked about 10 layers of infection. Well, you can think of these 4 transactions as like the 4 layers to where all the money goes. Okay. So out of the initial $75 that was spent, that $75 trickled into different people and was spent differently, but the total of it was 75 plus 60, okay, 75 for me, 60 for Jane, 30 for John, and then 30 for the waiter, and let's say his name is Sam, okay? So it's 60 plus 30, which is 90, or I'm sorry, 30 plus 30 is 60, 60 plus 60 is 120, and 120 plus 75 is 195. Did I do that right? 75, 60, 30. Yeah, okay, just want to make sure. So out of the initial $75 that was spent, the total collection of money that was spent through my initial $75 of expenditure was actually $195. And again, that's kind of how we talked about the infection rate, right? One person gets the coronavirus, and through 10 layers, they have a potential of infecting 59,000 people, okay? And it's not just at once, right? It's through that ripple effect. And so similarly, that's how the multiplier effect works. And so if you wanted to know, okay, well, how do you calculate the multiplier? And calculating the multiplier would be kind of equivalent, if we're keeping the analogy, of calculating how many people does the flu infect versus the coronavirus effect, right? So the multiplier would be like the 1 to 1.44 for the flu, the 3 to 3.3 for the coronavirus, right? The actual infection rate, not the infection spread, but the infection rate, okay? So the first thing before you can calculate that is there's 2 assumptions that are essential to maintaining when you're using the general model of the multiplier effect and how the government works with that. Okay, so the first assumption is that for every dollar that is spent, there's only 2 options that is possible for that dollar. It either gets spent or it either gets saved. Okay, there's only 2 things you can do with money. You either can consume it or you can save it. And again, that keeps in holding with the example that we just did about the trickle effect of the money through expenditure. And then the second one is that the MPC, or the marginal propensity to consume, is the same for everyone throughout the entire economy. Now, obviously, you might be thinking, well, how can that be true? That's not the same. That's not true. We know that, but when we're using a model, right, we're doing our best to have some type of construction and some type of, parameters into which we can estimate and extrapolate what we think might happen in the market. Because there's no way of us ever being able to know every individual's marginal propensity to consume, right? So we kind of just have to create some assumptions, and then based off of the assumptions and keeping in line with the model, those are the results that we'll get, okay? So let's take a quick mathematical example, all right? We'll use the $100 that I initially had, right? And I said I spent 75, which means by default, the $25 must be saved. And remember, again, the first assumption is that you can either consume or save, right? Which means by default, the second assumption means the MPC is the same for everyone in the economy, which means the MPS will also be same for everybody in the economy, right? So in this case, the MPC is 0.75, right? We take part over whole. That's how we get we consume $75 of a total of 100. So that's how we get 0.75. And the MPS, or the marginal propensity to save, is the amount we saved divided by the total we had, which is how we get 0.25. The MPS plus the MPC must equal 1. 75 plus 25 must equal 1. Must equal 100, 0.75 plus 0.25 must equal 1. Again, because the assumption is that you can only consume or save, and it's essential to remember that, okay? So now that we have that established, we need to establish this first before we can establish the multiplier effect itself. So when we're talking about the multiplier effect, again, you can think of it comparable to the infection rate itself. Is it 1.1 to 1.4 or 3 to 3.3? What is that number, right? We'll do 1 divided by MPS. And the reason it's divided by the marginal propensity to save is because this is the money that's not flowing through the economy, right? This is the percentage of money that people are keeping at home. They're not spending it. It's being saved. So in this case, if we keep this same example, 1 divided by 0.25 equals 4. That 4 is the multiplier effect. So if, for example, say the government decided to inject $2 trillion into the economy, and they inject that $2 trillion and the multiplier is 4, that $2 trillion through multiple expenditures will actually end up being a total of $8 trillion of money through transactions, through expenditures, so on and so forth. $8 trillion worth of money flowing through the economy in some way, shape, or form. And so that is why the multiplier effect is so important. And it's important to remember that this is a very foundational level of what the multiplier effect is. There's the spending multiplier and the monetary multiplier, but when it comes to the math and the ideology behind it, they're kind of the same. And the reason the multiplier effect is so important is because A, if the government wants a total spending of example for $10 trillion, say that, for example, right now, we'll expect to see a lot of government spending to get us out of the recession that's coming, right? So if the government wants a total of $10 trillion being spent, and say the multiplier effect is 5, that means the government will initially inject $2 trillion into the economy. They will only inject $2 trillion, and that will expand to the 10 trillion that they're hoping for. Because if they initially inject $10 trillion into the economy and the multiplier effect is 5, that means that will end up being $50 trillion that's circulating through the economy. And if you're like, well, that doesn't sound so bad, that sounds kind of good. The reason that's not great is because, again, we do want a certain level of spending and saving that's happening, right? Because if people are having a high propensity to consume, or the way you can think of it is they have a high propensity to spend, that might mean that people are living paycheck to paycheck. They can't afford to save. Panic buying is a temporary example of high propensity to consume, right? And when we're talking about if we have a higher propensity to consume, we have to worry, how long is that going to last? Because if it's a very long-term thing, that means people aren't saving money. And we can't have investments without saving money. People can't buy houses, people can't buy cars, businesses can't open. If you're a sole-owned business, you can't open because you're not getting enough investment, right? And we don't want people always spending, because that's, it initially leads to, people will get jobs because people are overproducing. But guess what? That also leads to inflation. And when there's high inflation, that means the cost of living gets higher. And if wages aren't matching that higher cost of living, which they won't, then eventually that's going to lead to a cycle of another recession, okay? And that's kind of like the self-correcting act of the classical model, if you will. And we'll get into that a whole nother day. And conversely, if people are having a high propensity to save, that is also worrisome. Because if people are saving a lot of money, then we have to look at how much investment is happening, because a lot of the US GDP is made through investment. So if people are saving a lot, but they're not investing their savings into something, that means people might be anticipating a recession to come, or they're not confident in the economy. So even if, economists and the Fed thinks the economy is good, and, they're like, we don't know why people think the economy is bad, that is almost irrelevant. It's not irrelevant completely, but it's worrisome, because it's like, well, people are not trusting what's going on. People are still saving. People aren't spending enough. Why aren't they moving this money through the economy, right? And when people are saving a lot, obviously then consumption is not happening through the economy. And then eventually the government will have to inject money into the economy to try to stimulate businesses to keep producing and stimulate that consumer confidence to spend. So really, the act of consumption and savings is all a balancing act. And that kind of goes in hand with fiscal policy and monetary policy. And, should the government get involved, or should they let the economy correct itself? Those are all things that fall within the theories of, Keynesian versus classical and fiscal versus monetary. But that is the reason the multiplier effect is so important, because the multiplier itself gives us an indicator of how much are people spending versus how much are people saving. And we can use that in conjunction with other data to determine if, everything's kind of in line, or that there's some troubling signs and, things aren't necessarily adding up, or there's something to be worried about, or the government needs to take action or something like that. So I hope you found this video useful, and tomorrow we will kind of use this multiplier effect as a foundation to explain how banks make money and how they kind of move money throughout the economy, and how that helps keep loans afloat, businesses afloat, and, how the money circulates through the economy. So I will see y'all tomorrow. Bye.